So taking a look at the first problem, who can figure out what they did here? Hey, Cooper's got an idea. Go ahead.
They broke it up to 10 into 2.
So they took the 20 and they broke it apart in 10 and a 2, which I can kind of see that down here, can't you?
Yeah, and then you divide it by 10, which drops it down to 42, and then you divide the 42 by 2.
Okay, so it's kind of like 3 steps.
Right.
What property is this where you decompose? It's not the decomposing.
It's partial products.
No, good try. Good try, though. Starts with a D.
Decomposition.
You're good. Distributive property. Distributive. Okay. So Cooper's right. That drops it down to 42. Why does it drop it down to 42?
Because we're dividing by 10, so you just take the 0 off.
Okay. So here are a couple ways we have done this problem. One way is we pop the decimal backwards 1 because we're dividing. Okay. Another way is if both numbers are whole numbers that end in 0, what can you do? Cross off zeros, okay? So then I take that 42 and divide it by 2, and what do you get for an answer? 21. Now, should we check that on a calculator? Let's do.
Should I check Ellis too?
Oh, no, it's okay. So what do I need to put in my calculator?
420.
Divided by?
20.
Did it work?
21.
It did. Okay, so you want to try the next one?
Mm-hmm.
Give the next one a try. We already know what they divided it into, don't we? Whoops. So what's an easy way to do 68 divided by 2, Preston? 8 divided by 2 is, and 6 divided by 2 is?
3.
So I'm splitting 30 apart into what?
So 10 to 3.
10 and 3. And that takes it, if I divide by 10, I like how Cooper said, takes it down to 96.
I divided it by 3 and I saw that.
And then I what? 6 divided by 3 and 9 divided by 3. Okay? So let's look at the next. Now there's several of these. And I want to make sure. So on unit conversions, we're actually making it a little more difficult. Instead of doing 1 foot, 2 feet, 3 feet, we're doing feet plus inches. So I'm going to tell you what I'm thinking on the first few of these, and then after that, you can just tell me the answer. Now, can you write and talk and think at the same time?
Yeah.
That's 3 things. So get your pencil and get ready to write, talk, and think. Okay? So 1 foot equals how many inches?
12.
12. 1 foot plus 1 inch
13.
equals, good. 1 foot plus 2.
14.
So you did 12 plus 2.
Yeah.
1 foot plus 3 inches.
15.
Okay, now think about this one.
22.
12 inches plus 10 inches. Don't answer before I ask it. Okay? 12 inches plus 8.
20.
Now, how come I'm saying 12 inches here instead of 1 foot?
Because 1 foot is 12 inches.
And it's
we're
easier
trying
to add inches plus inches, isn't it? Okay, let's keep going. And somebody besides, I need all of you to talk and think and write, not just Cooper. Okay?
Oh, I'm ready.
All right. Well, you better be right.
I'm done.
2 feet plus is equal to how many?
24.
Now, I know okay, keep going. 2 feet plus 1 inch.
25.
24 plus 10.
34.
24 plus 6.
30.
Okay. 3 feet.
36.
Oh, you know your 12s?
Yeah.
Okay. 3 feet plus 10 inches.
6.
Awesome. 3 feet plus 4 inches.
40.
Okay. The next activity is a little different. We're starting with inches and going to feet. Okay? So what if I had 2 inches? How many feet would that be? 0. Okay, what about 3 inches?
We have
How many inches, or how many feet is 3 inches?
0.
And 3 inches, right? Now I think they started with 0 so you would know that we're going to have a whole number here that's something about the feet. So 14 inches.
1
1 foot.
and 2 inches.
Now here's what I did in my head. I did 14 minus 12. How many are left over? Okay? So 22 minus 12 is 1 foot. How many are left over? 10. Okay? 24 inches. 2 feet. Hint, there's not another line over there, right? Okay, so 34 inches, I'm going to subtract 24. That would be 2 feet. How many are left over? 10. 25 inches. 2 feet, 1 inch. So 36 inches.
3 feet.
3 feet. Because 3 times 12 is 36. So to figure out the next one, I'll do 46 minus 36. That's 3 feet. How many are left over? Okay, what about 40 inches?
3 feet and 4 inches.
Awesome. 48 inches.
4.
4 feet. 47 inches.
3 and 11.
3 feet, 11 inches. 49 inches.
4 and 1.
4 feet, 1 inch. 58 inches.
4 and 10.
All right, let's keep going. This is fun. I sort of like how they started this. Now, I'm going to give you a lot of information right now, Cooper, that you're going to need. So I want you to pay attention, okay? All right, so let's just say I had 4 copies of 1 banana. How many bananas would I have? 4, okay? I can do the same thing with fractions. 4 copies of 1/7 would be 4/7. Notice this is unit form. Now I'm going to write it in standard form. So 4 copies of 1/7 would equal 4/7. Okay? So let's keep going. 7 copies of 1/7 equals 7/7. Now write it in standard form. And here's what you do in 5th grade. Are you watching? 7/7 equals what?
1.
Or 1 whole.
I
Okay.
just put 1.
I want both of them in 5th grade, and there's a reason for it, okay? Because we have a lot of mixed numbers that we deal with eventually. Now, let's keep going to the next one. 14 copies of 1/7 would be what? 14/7. So 14 times 1/7 equals. Now, here's one reason why I want you to go ahead and write 7/7. When you were in 4th grade, you probably did it like this.
What?
Remember that?
Yeah.
Okay. And so that shows me that it's how many whole? 2 whole. So then beside it, I'm going to write 2 whole. Now, there's more. 5th grade knows more. Okay? What are all the ways to write a division sign? The doghouse, right? Okay, what else? The line with the 2 dots. Okay? And then a straight line, or sometimes on your keyboard it's a slash. This really means 14 divided by 7. So
Equals 2.
all I have to do is divide. I know. I'm going to tell you something else here in a minute, so pay attention. This is fun, isn't it? 8 copies of 1/4 equals So 8 times 1/4 equals 8/4. 8 divided by 4 equals 2. Okay, now I noticed something about this. I want you to stop and take a look at it. I notice that my denominator is not changing. If I start with a banana, I end with a banana. If I start with a 7th, I end with a 7th. Okay? There's a way to do this so that it really makes sense. If I am multiplying fractions, and I'm just going to use one that we already had. Give me one we already had. 14 times 1/7? Okay, so this is the problem right here, 14 times 1/7. Now when I multiply fractions, I multiply straight across, okay? But if I multiply this straight across, I might end up with 14 times 1 over 14 times 7. That will not work, okay? So here's the rule for dividing whole numbers and fractions. You can turn any whole number into a fraction. All you have to do is write 14 divided by 1, because what's the answer to 14 divided by 1? 14, okay? So it doesn't change the value of it. Are you watching? Now I just multiply straight across. 14 times 1 equals, and 1 times 7 equals, and then 14 divided by 7 equals 2. Did that just change your life? Don't you wish you would have known that yesterday on the math test? I bet you got some multiplying fractions problems, and now you know you just multiply the numbers straight across, okay? Let's keep going. 12 times 1/4 equals, so 12/4 equals what whole number? 3. Because 12 divided by 4 equals, okay. You want to try the rest of these on your own? I'll pull a stick for someone to come and write before I turn the page. So see how 1/3 is written in unit form? I'm just converting it to standard form and writing the fraction instead of the number in the word, okay? All right, let's keep going. What's on this page? Oh, this is fun. Now I need you to do something for me. I need you to copy down what I did right here. And you need to be able, are you watching? You have to leave room for your bracket and some words on the top row. And then on the bottom row, I actually probably need to move mine down a little bit, because I've got to leave room for words underneath and then a bracket on top. So go ahead and make 5 tape diagrams. There needs to be 5 of them. And 3 on top, 2 on the bottom, if you can make it fit. If not, you might have extra space somewhere else. But this is going to be a resource for us in the future.
Wait, I haven't really.
Stop. So I need you to have excellent handwriting so you can read it. So you should have your tape diagrams drawn correctly. And remember, I need you to have nice handwriting on this. Okay, so let's read number 1. Express one day as a fraction of the week. So what are my 2 measurement words? Day and week. Which one is a larger unit? Week. So that's going on top of the tape diagram. 1 week. And you can abbreviate. Okay, so now if I have 1 week, how many equal parts will I need for days? 7. So put 7 equal parts. And if I have 1 day, I'm going to shade 1 box. Now see how we shade in 5th grade. It's non-negotiable, so eyes up here. You draw lines. And there's a reason for it. You don't color in, you draw lines. Well, fix it. Or don't do that again, okay? Because this is how we have to do it. Now, I'm going to write something down here and I want you to think, don't shout it out. So 1 day equals blank week. I want you to think about what you might put on the line, but don't shout it out. Now, there's no way it can be a whole number because I'm starting with 1 week as my unit.
One day.
So what would 1 day be? What do you think, Robert?
1/7.
You're right.
But today we are.
You guys are so smart. So 1 day equals 1/7 of a week. Okay? Let's keep going. Number 2, what are my 2 measurement words? Express 1 foot as a fraction of a yard.
Foot and yard.
Foot and yard. Which one of those is larger?
Yard.
That goes on top of the tape diagram. You could do 1 YD. I wonder why I have these 3 rulers on the floor here. Any ideas, Cooper?
Nope.
How many feet are in a yard? 3. Okay, you were thinking meter. We're going to get to that. We're going to get to meter. But it's 3 feet in a yard. Something interesting happened in block 2.
What?
So I've got 1 foot that I'm going to shade. Okay. Mrs. Settlemeyer was lining her students up for maybe PE or something. And she said, okay, you can't go to PE till you tell me how many feet are in a yard. And Channing walked by and she said, 3. So she kind of got in trouble. But isn't that interesting that we're talking about the same thing as 4th grade?
Wait, she walked right by Mrs. Settlemeyer and said that?
Because she was at the restrooms. So I think it's interesting that both grade levels are talking about how many feet in a yard. You're not going to forget,
Yeah,
are
'cause
you?
we're getting
Because
reminded.
you have a visual right here on the floor, and I think I'm going to leave it here all year.
Oh my.
And you'll never
Well, how are we
forget.
gonna lay there during story time?
Okay, so yeah, well, I do read to the students, and it's the favorite thing of,
Yeah, we get pillows.
but it doesn't happen very often. Let's keep going
Because
though,
they're not.
okay? So now I'm going to write 1 foot equals blank yard. And if you use what we did on the days and the week, Aubrey, what do you think I'm going to put?
What?
Now I did 1 out of 7 here. So what will I do on the yard?
1 out of 3.
1 out of 3. Which is how we used to say fractions when I taught the younger grades. Okay? 1 part out of 3 parts. Very good. Good job, Aubrey. Okay, look at the next one. Quarts and gallons.
Quart and gallon.
Okay, good.
Gallon.
So which one's larger? Gallon. Okay. And I'm going to abbreviate that as GAL. Who knows how many quarts are in a gallon? Cooper?
4.
Okay. So now we have 1 quart as a fraction of a gallon. Quart is QT, kind of like Quick Trip. 1 quart equals blank gallon. So, Justin, what do you think goes in the blank?
1/4.
1/4, or 1 out of 4. Okay, now you have to see, and Cooper, don't spoil this story I'm going to tell, okay?
Is it the?
Just don't spoil the story. Now, this is, I always called it the big G, but it helps with gallons, quarts, cups, and pints.
No, you need to draw a real big G.
I am going to draw a big G. Now,
Can I make
Nicole went to 4th grade in South Carolina. And they taught the big G, but they gave a little story to go along with it. And the story goes like this. There was a kingdom called, and we named it in block 2, Gondor, from Lord of the Rings, okay? There was a kingdom called Gondor. The kingdom had 4 queens. Oh no, 4 women in charge.
Dun dun dun.
Each queen
had had two peasants.
had two princesses. Cooper's got peasants on the mind.
That's what he is.
No, just teasing. And then we couldn't quite decide. Nicole said in South Carolina, they said each princess had two cats. But I said it could be two children, technically, because child starts with a C, okay? As long as you know that each princess had two something or other that starts with a C. And there's your story that explains
They had two
customary measurement, 2 cows. Okay, that makes sense. So here's what I know. 1 gallon has 4 queens, which is quarts, right?
Yeah.
And
8.
8 pints, which is princesses. That looks like pence, doesn't it? But it's pints. And how many cats?
16.
16 cups. So now when you've got a question about
Wait,
this.
maybe they could be like big cats.
They could, like tigers.
Lion.
Okay,
Because
just a minute.
stuff like that.
So if you need to know this for anything like a map assessment, now you know. Think back to your kingdom, okay? So I don't want you to ever forget your big G kingdom, okay?
All
right.
We didn't record the kingdom.
Yes, we did. I recorded it.
That was funny.
Okay, I did.
She hasn't stopped the recording.
I just paused it when I was telling the story, okay? So let's go down to 4 and 5 because they're a little different. How are they different?
One fraction.
Ella, how are
it's in
4
a
and 5
decimal
different?
form.
Says decimal form. What else is different about it?
7
It's-
And what is that, Aubrey? It's not customary units. What is it?
Measurement.
Starts with an M. Met.
Metric.
Metric.
I
Good.
thought you were gonna call them.
Okay, so I asked Aubrey. So I've got 2 units of measurements. What are they? Centimeters and meters. And which one's largest?
Meter.
Meters.
A meter.
Okay. Now, I don't know about you, but I do not want to draw 100 boxes.
Me too.
Forgot. I told you how many centimeters are in a meter. Did you know that already? Okay. So instead of that, I'm going to do that trick.
What trick?
The one where I do this, and so on and so forth. I'm recording. So now I've got, what will my last 2 numbers be?
99 and 100.
99 and 100, good. So I've got, and this is going to be kind of hard to see, so I'll make it in white. 1 centimeter equals blank meter, and it has to be written as a decimal.
Oh my gosh.
So what in the world am I going to write? Think about it Fernando, what do you think?
100.
You're right. How do I write 100th as a decimal? Right there. Now what if I needed a fraction? We know that, don't we? Okay. So, but today it's asking for decimal form, so I don't need the fraction. Very good.
There's 100.
Okay, so I'm going back to the next one. This one's a little different. So I've got, what are my 2 units of measurement?
Meter.
Meter and kilometer. Which one's the largest?
Kilometer.
Kilometer, good. Kilo.
Kilo.
So 1 kilometer. How many meters do you think are in a kilometer? Kilo means,
1,000.
so how many meters do you think are in a kilometer?
1,000.
1,000. So I'll have 1, 2, 3, ... What are my last 2 numbers?
199,000.
And I can't fit them right under, but I want to be able to read them. Okay? All right, now I need to know how much 1 meter is if my label is going to be kilometers. Oh, guess what I forgot to do? Shade. Shade. All right. So 1 meter, Justin, equals how many kilometers? 1,000. And I usually say a 1,000th of a kilometer. But you don't have to. You can say 1,000 kilometers. Okay, and how would that look as a fraction?
1,000.
1 over or 1 out of 1,000. Okay? All right, time for the lesson. This is going to be fun.
Wait, it's not even.
I know. And we only have just 3 more boxes, and then you can probably work on Zern. Okay, yeah. So here we go, problem 1. Now, remember, we're teaching a strategy, correct? So the strategy is a little different. How many equal signs do you see?
3.
4, okay?
I see.
Okay, now just a minute, all right? Now, we already know the answer to how many weeks 14 days is, so get that out of the way. What is it? 2. Write it down. But how does this look with our previous strategy? Okay, so 14 days is the same thing as 4 copies of one what? 1 day. Which we already know 1 unit is going to have the same label, right? So now we've got to figure out, okay, well, how many weeks is 1 day?
It's 1/7.
You're right. We just did it back here, didn't we? 1 day equals how many weeks?
1/7.
Right. So that's why I said that's going to be a resource page for you if you need it. Okay? So now I simply multiply. 14 copies of 1/7 is what?
2.
14 sevenths. That's where your extra equal sign comes in. Now 14 divided by 7 equals 2. And this is all starting to make sense, isn't it, boys and girls?
Yes.
Very fun math. Okay, so the next one, we've got to figure out how many yards 24 feet is. Okay? So in order to do that, 24 feet is 24 copies of what? 1 foot. Now, do you remember when I said just write a 1 and keep your label the same? Well, that doesn't work with feet and foot, does it? No. Okay, so then I need to figure out, okay, 1 foot equals how many yards?
3.
You're close. There is a 3.
Oh, 1/3.
1/3 yard. Or 1/3 yards. So then 24 copies of 1/3 is 24 what? 24 what? 24 thirds. And 24 divided by 3 equals, so 24 feet is 8 yards. Too fun. Okay. So now how many gallons is 24 quarts? Well, 24 quarts, this is how Dwayne said it, is 24 copies of 1 quart. 1 quart is equal to how many gallons?
1/4.
1/4 gallons, which we know from the other page, right? And 24 copies of 1/4. What fraction do I have?
24.
24 fourths. Do I have a new student? 24 divided by 4
6.
equals? All right. So how you doing? Pretty fun, isn't it? Let's go on. We've got some more. These are probably metric. Yes, they are. Okay, so let's get this out of the way right now. Which measurement in 5th grade has 100 units in it?
Centimeters.
Okay, just like century is 100 years. All the rest that we have used so far are 1,000. Okay, so let's take a look at it. We've got to figure out how many meters 195 centimeters is.
It is.
Now, just a minute. See if you're right.
Almost.
So I've got 95 copies of 1 centimeter, right? Because my labels stay the same. And 1 centimeter equals how many meters? One what, Justin? 100th meters. And how do I do this problem now? We did it a few days ago.
What do you mean?
Well, we had a decimal times a whole number. Do you remember what we did? I'm going to write it bigger. Okay, now, let me talk, Cooper. When I multiply, normally my answer gets larger. When I multiply times a whole number. What if I multiply times a fraction? It doesn't stay the same.
It gets
Oh,
bigger.
you would put a decimal.
Okay, stop and think before you answer. If I multiply times 1, my answer is going to be the same. If I multiply times 2, my answer is going to be larger. What if I multiply times less than 1? My answer gets what?
Smaller.
Smaller. We talked about this a few days ago.
Because so you drop the decimal where after the 1, so between the 1 and the 9.
Let's see if he's right. So how many decimal place values is this?
2.
2. So I'm going backwards 2 because I'm actually dividing. So what do I have? Is he right? The decimal's after the 1?
Yes.
Uh-huh. It is. And it makes sense if you think of it like that. When I multiply times a number that's less than 1, my answer is going to be less than what I started with. So you wouldn't want to make this 19,500. That makes no sense because it's got to be less than what you started with. Okay, let's go across to grams and kilograms. So 4,500 grams is 4,500 copies of what? 1 gram. Okay. 1 gram, Alondra, is equal to how many kilograms? Okay, let's go back. How many grams are in a kilogram? 1,000, right? So if 1 gram's the tiny one, I'm going to have less than 1 to figure out how many kilograms. Could we use what we did on the tape diagrams? So it's going to be the milliliter one. Look at the milliliter one on the tape diagram. Don't we have 1,000 milliliters in a liter? So 1 milliliter was equal to 1,000 liters, right? This would be 1,000 kilograms. So basically it's just opposite. Instead of 1,000, it's 1,000. So how do I do this one? How many decimal place values?
3.
So I'm going backwards 3. What's my answer? 4 and 5/10. 4 and 500 thousandths. It's easier to write 4 and 5/10. Okay, let's take a look at this one. This is the liters and milliliters, like I was just talking about. So I've got 578 milliliters. Ella, tell me what it is. 578 copies of what? 1 milliliter. Remember, keep your labels the same. By the way, this is sort of like an algorithm, isn't it? It's just for figuring measurements. Okay, now, I've got to figure out 1 milliliter is equal to how many liters, Caden? What do you think? Fernando, I can't tell you're paying attention. How many liters is 1 milliliter equal to?
1,000.
I asked Caden, but oh well. Gotta squeeze my decimal in. So 1,000th has how many decimal place values?
3.
So I will go Backwards how many
So 0 and 578,000.
liters? Okay, 2 more problems.
I thought that was the exit ticket.
No. Oh, here we go again.
We need to take that.
Okay. Yeah. Whatever you want the story to be. So 16 cups is equal to 16 copies of one what? You can write 1C. It has to be a lowercase though. Okay. Now this one's written differently, but do you still see 4 equal signs? Yes. Whenever you're going to write a fraction, you're going to have 4 equal signs. I put this one differently so that you'll be able to apply the 4 equal signs to a different order, okay? But I still have 1, 2, 3, 4. Okay, so I've got to figure out how many pints. 1 cup is equal to how many pints? Well, let's see. If I have 1 cup,
It's 1 half.
it's 1/2 or 1 out of 2.
So wait. What do we
So I'm going to write 1/2 pints. And then I multiply 16 times 1. So I have how many pints? 16 halves. And 16 divided by 2 equals. Now let's go back and look. Is that right? Do I have 8 pints in 16 cups?
Yes.
Yes, I do. Okay. 1 more, boys and girls. And block 1 told me your line up here is too small. So I made it longer for next year's class. So who can say this number, Mia? Go ahead.
1,675,280.
You're right.
Good job.
Very good. So that's 1,675,280 copies of what? 1 gram. Good. Now, 1 gram is equal to how many kilograms?
1,000.
1,000. How many place values? To the right of the decimal.
3.
3. So how many backwards hops?
3.
How do you say the answer, Ella?
1,675 and 228.
Good. Could you have written 280 thousandths though and been right? Yes. Okay, good job.
But you don't need the